For the final type of reaction in this unit, we're going to be looking at single replacement reactions. So there are a broad range of single replacement reactions, but in this unit, all the ones we're going to focus on are between a metal and an acid. And so here in this video that I'll play in a moment, I have magnesium metal, which is a solid, and then a hydrochloric acid, which is, of course, aqueous. So I'm going to add the magnesium metal to the acid, which we saw in experiment 17. So when I add the metal to the acid, you can start to see it bubbling. So what's happening while the magnesium is bubbling? The magnesium and hydrogen are switching places. The magnesium is replacing the hydrogen, thus single replacement. So this is like double replacement, but instead of having two ionic compounds, we have one pure element, the magnesium, and one ionic compound, or quasi-ionic compound, hydrochloric acid. So when these two substances switch, then we're going to get hydrogen gas, which is the bubbles you're seeing, and magnesium chloride, a new ionic compound. So in single replacement reactions, we have a solid metal reacting with acid, and that's going to produce hydrogen gas and magnesium chloride, or another ionic compound containing the metal that we started with. Let's zoom in and take a closer look at what's going on in this reaction. And so right now we have our starting solution, our reactant hydrochloric acid. So remember, hydrochloric acid dissolves, the H and the Cl split up. And so on this left side, our circles are really hydrogen ions with a charge of +1, and our triangles are really chloride ions with a charge of -1. And so when this reaction starts, we put in a big chunk of magnesium metal. So when the magnesium starts reacting with the hydrochloric acid, the magnesium and the hydrogens are switching places. So what that means is electrons are going from the magnesium, because this big block of magnesium is neutral magnesium. So it has valence electrons. And so the valence electrons are going from magnesium to the positive hydrogen ions. So these are electrons. Remember, E- is an electron. So electrons going from magnesium to hydrogen. So what that's going to do is magnesium ions are going to come off of the piece of magnesium that was put into the solution. And then in their place, hydrogen atoms are going to start to pair up to form hydrogen molecules, these H2 molecules up here, and they're going to start floating off into the air by themselves. And they're going to leave these chloride ions behind. So remember, there's 2 chlorines to every 1 magnesium based on like the balancing of our chemical equation. And so now in our products, we have neutral hydrogen, H2, but then our magnesium is now Mg +2, because the electrons that the neutral magnesium had in our reactants go to hydrogen in the product. So the positive charge that hydrogen has is now on the magnesium. And then the chlorines, still negative. It doesn't change at all. And so that's how single replacement reactions work. The big thing that you need to remember: in single replacement reactions with acids, we're always going to have a metal as one of our reactants. It's going to react with the acid, and then we're going to get hydrogen gas as a product, and then an ionic compound containing the metal we started with. So that's for all single replacement reactions with acids.